Hey there, I'm doing some screencasts on related rates problems. This one is about the growth of a rectangle. I'll read the problem to you. A rectangle that is twice as long as it is wide is growing. Specifically, its width is growing at a constant rate of 3 inches per minute. How fast is the area of the rectangle growing when the rectangle is 6 inches by 12 inches? When you work a word problem like this, one of the things you need to do is translate the English into mathematics. That is to say, here we have a verbal representation of a function somewhere in there. Now we want to change that representation to symbolic. So that's one thing we need to do. Another thing we need to do is figure out what is it trying to ask. Well, the question here at the end is how fast is the area of the rectangle growing? That's what we want to look for. That's our goal in the end. It's a rectangle. We know what the area of a rectangle is. We know that the area of a rectangle is its length times its width. So that's a formula we have. Maybe it'll be useful. What do we know about a rectangle? We know that it's twice as long as it's wide. So if I let L be the length of the rectangle, and W will be the width of the rectangle. It's twice as long as it is wide. So the length is 2 times W. So that means if we say A is the area of the rectangle, and area is length times width, length is twice the width, so our area formula is 2 times the width squared. We want to find how fast the area of the rectangle is growing. So that's a question about what's the derivative of the area with respect to time. One thing we know is the width is growing at a constant rate of 3 inches per minute. So we know that the width is growing, so the rate of change of the width is 3 inches per minute. Well, it's good to keep track of units like this and problems like this. So let's just specify that the length and the width are in inches. And so our area is going to be in square inches. And you can confirm that down here with our formula. If W is in inches, then W squared is in square inches. And that's the unit we expect on the area. So we know what the derivative of W is. We want to know what the derivative of area is. Here we have an equation that relates area and width. Now we can differentiate. So we're going to differentiate implicitly. So differentiating both sides, and the left side gives us dA dt, and the right side gives us 2 times 2w dw dt. Note that this 2 is this 2, and this 2w comes from the power rule on this w squared, so derivative of w squared is 2w. And then because we're thinking of w as a function of t, it's changing over time, implicit differentiation has us multiply, because of the chain rule, by the derivative of w. Okay? So we've got dA dt, which is what we're looking for, which is great. Now we need to be able to plug in something for everything on this side. We know dw dt is 3 inches per minute. Now I need to figure out what W is. Well, we're asked for the rate of change of the area, or how fast the area is changing, when the rectangle is 6 by 12 inches. Well, the length is twice the width, So here my width must be 6 because my length is 12. So this tells me W must be 6. So that's what we're going to plug into our equation here. 2 times 2 times 6 times 3. So that's 4 times 6 is 24 times 3 is 72. And our unit on that should be square inches per minute. So that's our answer. I might write that as a full sentence. The area is changing at a rate of 72 square inches per minute when the rectangle is 6 inches by 12 inches. And that's the solution. Now, this is a point in the screencast where I want you to pause and try a problem that's like this. So this problem is a square is growing in size. Specifically, its sides are growing at a constant rate of 2 inches per minute. How fast is the area of the square growing when sides are 8 inches long? There's a typo. Are 8 inches long. So using the model that I presented you on the previous problem, use those techniques and that approach to solve this problem. Pause the video, take some time to do that, and when you have an answer, come on back to the video and I'll show you what I got. Now that you've answered the question, the next question I want you to think about is this one. If the sides are growing now that you've answered the question, I'll tell you what my answer is. I get that the area of the square is growing at a rate of 32 square inches per minute. Hopefully you got the same answer. Now that you have an answer and you know what my answer is, I want you to think about one more thing. If the sides of the square are growing at a constant rate, is the area growing at a constant rate? You can think about this from your intuition by looking at maybe a couple squares and thinking about their area. Or you can look at the mathematics. And what does the mathematics tell you? I'd like you to consider this question and then use the mathematics to explain why the area grows in the way that you think it does. And then it's good to ask yourself, does this agree with your intuition? What does your gut tell you?